Hello students, let's discuss a common term, that is modulo, or understand the concept of addition modulo and multiplication modulo, which are the very common operations used in the mathematics. First, let us understand what is this addition modulo and what does this multiplication modulo means. Suppose we are given with two distinct integers a and b, and this m be a fixed positive integer. Then the addition modulo m, which is denoted by a plus mb, is defined as a plus mb equals to r, where this r is nothing but it is the least non-negative remainder when the sum of a plus b is divided by m. Means if we divide this, the sum of this a plus b by this fixed integer m, then the result will be our final addition modulo result. Same definition applies with the multiplication modulo, but in this case we multiply both the numbers. Let a, b are the two distinct integers and p be the fixed positive integer. It is fixed. The condition is that modulo under which we are calculating that digit should be fixed, that number should be fixed. Then the multiplication modulo is defined by, or it is denoted by a cross p b is defined by a cross pb is equals to r, where this r is the non-negative remainder when the ordinary product of a b is divided by m. Means in this case we are first multiplying both the numbers and then we are dividing that number by m, and the remainder will be our answer. In case of the addition modulo, when we are adding two numbers and then dividing by n, the remainder was your final addition modulo answer. Now let us take a problem from the group theory, which says that prove that the set J, which is defined by the set 1, 2 and 3, 4, is a abelian group under the operation multiplication modulo 5. Means here m is 5 and these are our numbers. Now let's first understand how to create this composition table. First, in this first row you need to write down your elements or your numbers, and same with this first column. Now you have to perform the multiplication modulo operation with these elements. Means first you have to multiply 1 by 1, and when we divide this by 5 it will give us remainder 1. Next is this column. For this entry we have to multiply this 2 into 1 divided by 5, that will give us 2. Same 3 into 1 divided by 5 it will give us remainder 3, and in the similar manner we will fill all the entries. It will give us the composition table. Now with the help of this composition table we can easily verify that whether the group is abelian group or not. Let us first understand the property, or let us first verify all the properties of the abelian group. The first property is closure one. Since all the elements in this composition tables are belongs to this group G, that's why it is a closure under this operation. Next property is associativity. For any A, B and C in this group G, we have A cross 5, B cross 5C will be equals to A cross 5B cross 5C. You can easily verify this by using this table. That means this associativity property is also hold. Third property is identity. Obviously you can easily find out that the 1 belongs to the G and which is the identity element. Now next the inverse is, for as we know that for every element A in G there exists an element B in G such that A cross 5B is equals to 1, which is equals to B cross 5A. This one is your identity element, and from the above table you can easily verify that the inverse of 1, 2, 3, 4 are 1, 3, 2 and 4. Last property is commutativity. The operation is commutative as the corresponding rows and columns in the composition tables are identical. For example, 3 cross 5 4 will be equals to 2, and which is equal to 4 cross 5 3. You can easily check it out from this composition table. Means suppose if we check this operation 3 4, the entry is 2, and if we check 4 3 means this operation, the entry is also 2. That means this is the commutative under this multiplication modulo operation. And since it satisfies all the properties of this abelian groups, that simply means this set is an abelian group under the operation of multiplication modulo 5. The only task is you have to create a composition table, and from this table you can easily verify that the given group is abelian or not.